Alright, so we should be back here, and let's see how we're doing. Hello, howdy, welcome. So the idea is we're going to go ahead and continue, try to solve this problem, give ourselves 2 hours, see how we do. This is going to be Design Twitter, it's called, Design Twitter. So we'll see how this goes. Let's get right into it. So normal. Design Twitter. Let's see what we got here. Daily check-in. Thanks. Design a simplified version of Twitter where users can post tweets, follow and unfollow another user, and is able to see the 10 most recent tweets in the user's newsfeed. Your design should support the following methods: post tweet, compose a new tweet, get newsfeed user ID, retrieve the 10 most recent tweet IDs in the user's newsfeed. Each item in the newsfeed must be posted by users who the user followed or by the user herself. Oh, it's a woman. It's a female tweeting. Tweets must be ordered from most recent, and let me just see, how's my voice? Yeah, it should be okay. Tweets must be ordered from most recent to least recent. Follower follows a followee. Follower ID, followee ID. Unfollow, follower ID, followee ID. Follower unfollows a followee. Do you like being called a followee? What are you going for Halloween? A followee? Or Folloween? Quit following me. Quit following me. I always thought that was kind of interesting that in real life, if you follow a woman, it's considered stalking. But on the internet, if you follow a woman, it's considered normal, encouraged social behavior. She's not a stalking victim. She's a followee. Okay, that's the next time you go to court for harassing a woman. No, look, I'm a follower and she's a followee. Okay, she's not a victim, all right? It's totally normal. Oh, it's good. That's fun. All right. So, anyway, Twitter, new Twitter. User 1 posts a new tweet. Post tweet. 1.5. ID is 5. The tweet IDs. Okay, well, it doesn't give you the string for the tweet. Post a new tweet. User 1's newsfeed should return a list with 1 tweet ID. 5. Twitter get newsfeed 1. Okay, so it'll be an array or vector of integers. Sure. So this shouldn't be too bad. This should be relatively simple. User 1's newsfeed should return a list with 2 tweet IDs. So mind you, we're not incorporating any databases in with this program. So this is all sort of localized stuff. User 1's newsfeed should return a list of 2 tweet IDs, 6 and 5. User 1's newsfeed should return a list. Okay. So, user ID, tweet ID. Okay. So user 1 is 5. User 1 follows user 2. User 2 posts a tweet ID tweet. And now user 1's feed is going to have 6 and 5. Tweet ID 6 should precede tweet ID 5 because it's posted after tweet ID 5. Tweet ID 6 should precede tweet ID 5 because it's posted after. Oh, okay. So the most, okay, I see, I think it makes sense. Twitter get newsfeed 1. So, excuse me. Yeah, we can use a vector as like a stack to get the most recent 10 IDs. I think, I don't know how often we want to flush the cache, flush the stack. But that works, the stack should be fine. Sort of, I think it's just a vector, really. Excuse me. User1 unfollows user2. Twitter unfollow 1 unfollows 2. User1's newsfeed should return a list with 1 tweet ID 5. Since user1 is no longer following user2, get newsfeed 1. So maybe we do actually want to have timestamps for the tweets, and then we basically would take like a, no, it doesn't have to be timestamp. Yeah, no, you do need a timestamp. I'm sorry, no, you do. What you'd want to do is, alternatively, it could be a global sort of count. It doesn't have to be like, there's a few different ways we could figure it out, but we could do it with a timestamp or a global sort of ID, and we would have, each user could have a list of their tweets, and then when you want to get the news feed for that particular user, it would be their tweet list, as well as all of the other, all of their followed, all the people that they follow, their tweet lists, and then you perform a kind of merge sort or a heap, like more like a heap. Yeah, it's like a, basically you would to create this news feed, you would basically merge the first, let's say, k elements from the, I think it's 10 elements, the first 10 elements from these different feeds, and you would use their respective, either we'll call them timestamps, or their respective timestamps, or the, what do you call that, the respective timestamps, or we said a custom count function that we're going to use. So we could do it that way too. Use a custom count, but we'll just call it a timestamp. And you want to do this somewhat efficiently. So if you have a lot of, the problem is if you have a lot of followers, then it could be, this algorithm would be linear in the number of followers, because you would take the sort of the first 5, excuse me, you basically would, you'd have probably just like, you'd have like a list of iterators starting at the beginning of each of these lists of tweets, and with their timestamps, and you want to take, you have to go through all of those iterators and take the one with the smallest timestamp, and you would do that 10 times, and you move the iterator for each of those. And obviously if you hit the end, then you don't count that iterator, you don't consider it. The problem with that algorithm, though, even it's relatively efficient because you have only 10, the list is only of size 10, you only iterate 10 times, so it's O of n with respect to the number of followers that you have, or the number of people you're following. However, and 10 is a small constant, so it's happening, it's a linear number of times. However, excuse me, this could be done a lot more efficiently if you were to, I believe you could do it more efficiently if you were to basically do a kind of merging where you take the first 10 elements of every list, and then you merge every other list. No, I think, yeah, you merge every other list for the first 10 elements of those, and then that's still linear time though, just doing that alone. I'm not sure if you could do better than linear time. Now that I'm thinking about it. Maybe a better thing to do would be Maybe a better thing to do would be to maintain this news feed as you follow someone or you unfollow. Maybe that would be better. So that way, when you follow the person, that then gets merged into your news feed. I'm just wondering, I'm thinking about it, like how can we do this more efficiently? How can we do this more efficiently? We probably would want, because following is constant time and unfollowing is constant time. However, the news feed would be linear in the number of followees. And tweeting is constant time. Can we load balance in such a way where we can maybe make all these things logarithmic, or just at least make the getting the news feed, make that like logarithmic or constant, and then make the other operations. Oh, ideally we want to make everything logarithmic. Maybe if that's possible, we could think of a clever way to possibly do that. Maybe we can even do better than that. So the problem with trying to connect the posting of the tweets, the following, the unfollowing with the news feed is that if you post the tweet, you've got to update all of the people that are following you. Which actually makes the posting of the tweet become linear in the number of followers, which is kind of awkward because that doesn't really solve your problem, does it? Doesn't really solve your problem, does it? Either getting the news feed is linear in the number of followees, or posting a tweet is linear in the number of followers. Yeah, it's kind of awkward, isn't it? I think generating the news feed on the spot is probably the way to go, by considering all of the people that you're following. You could actually do it better than what I just described, because you could take what you can do is take well, it's still linear anyway, it doesn't really matter. I was going to say you can make things somewhat more efficient where you can take all these elements. You know what you could do? You could keep, here's an idea. Okay, I got an idea. You keep your followees sorted with respect to their most recent post. So but you still have linear time every time you post if you do that. It's kind of a lot. That's kind of a lot. Basically, if you keep all of your, well, man, this is not great. So if you keep all of, if for each, I guess, user ID, each user, if you keep your list of tweets for each followee and you keep that list sorted by the first tweet, obviously those are all sorted as well, you keep it sorted by the first tweet, and then what you can do is you know immediately what the first tweet's going to be, and you can basically that once you shift the iterator to the next value, that would be you can basically put your iterators into a heap, and then so you can heapify your vector of iterators, and it's already sorted, it's already heapified, so to speak. Actually, it's already in a heap, I want to say, something like that. Or another way to express it is you keep these things in the heap. Yeah, you keep the heap, you maintain the heap structure of these iterators in this vector, and then you can, when you pop the smallest one, and you would remove it from the heap, increment to get the next value, and then push that into the heap, push the new iterator into the right spot in the heap, and it would take logarithmic time to remove and push. And so then you can find your 10 elements in logarithmic time rather than linear time, right? And which, by the way, you would reset these you would reset the pointers that you modified. Now, see, that's the thing that's kind of awkward. Is it would still take you linear time excuse me, to reheapify, to reset those pointers back to where they should be. Yeah, you'd have to copy this. That's not really what we want. By the way, you can, no, never mind. Excuse me. Just thinking, that gives you like O of n plus k log k. K is constant, it's just O of n. Yeah, that also isn't really that good because you still have that problem of like having to update and reheapify. Well, you could do it this way. Instead of doing linear adjustment, you can do O of k. Yeah, it's k log k anyway, because you can maintain a vector of all of the pointers that you modified, and then also maintain their original pointers. So then you can actually, yeah, pop and push those values back in, I suppose, from the heap. problem you run into though is removing nodes arbitrarily from the heap is kind of a tricky thing. I want to say you really would just want a set rather than a heap. A set's fine, you don't need a heap. A set is perfectly fine. Heap is linear to create in the first place. But if you're going to be doing all of these logarithmic operations anyway, you might as well just have a set that you create as you go. Sort of the set of the pointers to the front, sorted by their, and a multi-set you want to do, and then sorted by their, no, you don't want to do a multi-set, I take that back. Sorted by their accounts. Their sort of their tweet IDs, really. Or their timestamps. Yeah, you don't need a multi-set. And so you could remove, and it's really sorted by the pointers, the object that the pointer points to. And you have an associated, I guess, tweet that you want to update that pointer back to. Yeah, actually that could work. You could in logarithmic time you can get this news feed, klog k time, which would be constant in our case where k is small. However, you do have this problem now of when you post a tweet, now you've got to update all of the followers of that user, all of their respective sets. Got to re-update. Pop from the set the pointer for that follower. That's kind of interesting. It's linear in the number of followers. And then it'll be a logarithmic factor for the number of followees for that follower. I don't know. Hi. Good evening. Hi there, Garbi Mohammed. Hope your day's going well. Welcome, welcome. Hello, hello. Hello, hello. How are things? How are you? So, or just how are you, I should say. I should say how are things. How are things is kind of, what's the word for that? Kind of an empty phrasing, because I don't know you well enough to know how things are. Hope things are going well. Look at that, I can say. Yeah, see, that doesn't really fix the original problem though, which is when you get the news feed, the only problem we have is that this is linear in the number of followees. Maybe we'll just keep it simple. Try that first. We do want to see what the, oh, it doesn't say. Okay. So yeah, let's keep it simple to start with, and basically, depending on how often you would, what the metrics would be, how often people are posting tweets, and how often people are getting their news feed, and what's the proportion if more people are following, and not that many people are. If you've got like sort of central hubs where like one person is sort of like has tons and tons of followers, and then most people don't have very many followers, then it's better to optimize actually, I don't know. I'm thinking about it. Maybe it's better to do what I was saying before, where the tweeting updates all of the followers, because rather than when the follower wants the news feed, building it based off the number of followees. It kind of depends. Like, I think with something like Twitter, it's actually better to probably build a news feed locally on their machine, right, their browser, than it is to have the server, I guess, update in the database for every user. What this, like, optimize this function for every user, something like that. I don't know. It's a good question. Fine, and you? I'm reading the statement. Oh, you are? Oh, yeah. Here you go. Design a simplified version of Twitter where users can post tweets, follow, unfollow another user, and is able to see the most 10 recent tweets in the user's newsfeed. Your design should support the following methods. Post tweet, compose a news tweet, the user ID and a tweet ID. Get the newsfeed, user ID, retrieve the 10 most recent tweet IDs in the user's newsfeed. Each item in the newsfeed must be posted by users who the user followed or by the user herself. Tweets must be ordered from most recent to least recent. Followers follow Followee, follower ID, Followee ID, unfollow follower ID, Followee ID, follower unfollows a Followee. I think it's probably simplest to just build the newsfeed at each step. So what we're going to do is we're going to have a hash map of followers and it's a hash set actually of followers and followees. So when you follow someone, you get put into their set of followees, and when they follow you, so there's two sets. There's your set of followees that you're following, and then your set of followers are the people following you, right? And we're assuming also these IDs are unique. And we don't necessarily care actually who your followers are if we are going to do things with the newsfeed, where the newsfeed function actually generates your newsfeed. We don't even care who's following you for those things. So excuse me. So really we want to have a hash map. It's going to look like the following. It's going to be unordered map of integer, which is going to be the user IDs, to an unordered set of followers, or no, followees. And we're going to use right? And so when we post a tweet, also, we're going to have tweets are just going to have IDs, tweets, which now I also want to have, we're going to call this the tweet ID, or not tweet ID, but the post time, we'll call it. We'll start that off at 0. So obviously we're not really supporting too much with regard to asynchronicity, right? Everything's going to be synchronized, so we can, you could use a timestamp, but this is basically going to be like a pseudo timestamp. No constraints about the number of users or tweets. No, nothing. It doesn't say anything. Yeah, it's pretty open-ended. So we'll call it post time at 0. But you could use time since epoch if you're doing something asynchronously. That would be better. But anyway, don't need to worry about that. So we'll say this is going to be the tweets are going to have a pair, which is going to be the tweet ID and the time. And this is going to be, and it's going to be a vector. It's going to be really should be a set, I think, of pairs. It really could just be a vector because it's going to be sorted the way that we're going to add tweets to each user's list of tweets. And we're going to call this tweet list, or tweets by user, per user, something like this, these data structures. Now these things you could modify these things to actually be like databases, and you could have API calls that get these things, as a user as a key kind of a thing, and then you would get this data, something like that. I guess in like a real world implementation, this would be sort of like a key. You wouldn't necessarily have a hash map for each of these. I don't think so. Okay, so all right, So when you post a tweet, all that's going to happen, and these are going to be, I want to say they're sorted backwards. You push back. Yeah, the more recent tweet is going to be in the back, so they're going to be sort of backwards, somewhat backwards. When you post a tweet, you're going to take your tweets per user of your user ID, and by the way, I like snake case personally. The user ID, and the way that unordered maps work in C++ is just referencing this at all in your code, like so, is going to actually create by default whatever this object is and call its default constructor. So we already have a vector of these pairs, and we're going to push back. We're going to a pair, which we're going to make, and that pair is going to be the tweet ID, and we're going to increment the post time. We actually do the post time. It's just going to start off at 0. That's fine. And we're going to push that to the back. So that's adding the tweet to our particular user, tweets per user. Now following is we're going to update the followees per user, which we said unordered set. Which, yeah, it doesn't need to be ordered, right? It's just a list of the followees, and it just has some item potency here. It could actually be, it's actually, the reason why you want to do it this way, it's easier to remove and add to the set, and it has item potency. So if you follow someone multiple times, it's like you don't end up like kind of breaking things. So followees per user would take the follower ID, and we have this down here too. Follower ID. So followees, how does this work? So tweets per user, followees per user. So this, it's actually the followers list or set. And we want to insert this followee ID. So each user knows his or her own list of followees using their ID. And that's it, really simple. And then if they're there, if they're not there, then erasing is kind of meaningless. Right? Okay. So now, so it's really simple, following and unfollowing, really straightforward. And we don't really need anything in the constructor at the moment. Now getting the newsfeed is a tricky thing. Why not use a stack? The reason I don't use this, so this actually doubles up as a stack. The reason why I would use a vector instead of a stack is because when I want to actually get the most recent tweets from the vector, I would want to actually, you can actually, what do you call that? You can actually read off from back to, you know, from from back to 10 elements from the back of the vector, and that takes constant time per element. Whereas if you do it with a stack, you'd have to pop all of those and then push them back on, excuse me, in the right order that you pop them off, which is fine. You could do that, not really a big deal. Just the problem with that is it's kind of wonky and like a lot of extra work, a lot of extra code just to like read the back elements off. So that's why I would use a vector here instead of a stack. if that's what you're asking. If you're asking about a stack for the unordered set here, the reason I wouldn't use a stack for this set is that erasing from this set is a lot easier here. Insertion and deletion is like super simple and super efficient. So now, when we want to get our news feed for our user ID, we're going to loop 10 times over, and I guess we could put this constant somewhere. We'll just leave it. We'll just write it right in. So you're going to loop 10 times, and what you're going to do is grab the smallest element. You actually, let me think how we can do this. So you do something like the following. It's something like this, where I just want to see min element. Just want to see if we use a unary operator here. Yeah, we can use a comparator operator. So we're going to use a lambda function to do this. So what we're going to do is we have standard vector int ret, and we're going to say for int I equals 0, I is less than 10, plus I, return ret after the end of this, and we're going to say we're going to ret, and it's going to be pointers, right? And it's going to be this guy. These. It's actually a vector of these, which seems a little crazy. And it's going to be an iterator, const iterator. No, I'm sorry. It's a vector of const iterators. Of const iterators. Yeah. Pointers or iters. It's better. Okay. Yeah. So we have a vector of iterators of this type. Excuse me. And they're all set to, and they're going to initialize the beginning of. You're going to say for auto x in. It's going to be the followees per user of the user ID. And this is going to be the set for each integer in this set. We're going to get the tweets per user, right, of x. And we're going to get the beginning of that vector, and we're going to push that into our iters. Hopefully that makes some sense. Hopefully that makes sense. And then now we're going to, so we could start with create a vector of iterators to the beginning of each followees tweets. And actually we want to go to the back. We want to go rbegin. We want to do it in reverse, right? I think we mentioned that the beginning to the most recent of each followees tweets. Right, we want to go for the beginning because we are, I think we do const, is it const reverse iterator? I don't know. I don't actually know if that matters or not. Reverse iterator, string iterator. Or modifying the collection. Well, we're not modifying it. Can I don't know what the type looks like for the iterator. I don't know. We'll find out. Let's see if it matters if this is a reverse iterator or not. I don't know. Anyway, we'll see what we get. See if this gives me problems or not. Just keep that in a mental note. I mean, obviously, I'm always learning more about C++ as I work with it. Thanks. Yeah, absolutely. Obviously, I'm learning more about C++ as I'm working with it. So we'll see if we have issues with this or not. But we may or may not have compiler issues with this const, or just some issue with this const iterator, even though it's because we're using a reverse iterator. Okay, so now we push all these iterators, and now what we want to do is take for auto it in iters. Oh no, excuse me. Oh no, there's one. Okay. And the problem we might run into is I want to use min element with the custom comparison function. However, these iterators at each step, we're going to increment these iterators, the ones that we pick. Excuse me. And we want to skip a couple of things. We want to skip the iterators that are already at the end of the sequence. And we also, from consideration, and then also if we're basically, we don't have 10 tweets to look at, we also don't want to dereference. So we could do something like this. Let's call it is going to be min standard min element of iters.begin, iters.end. Oops. And we're going to say lambda, or just m. I just tend to pick m for my, if I don't really know what I want to call my lambda function, I'll just give it a const standard. Now this is a pair of ints p, and it's actually two of them that we're comparing to each other. And we want to say these are actually iterators themselves. They're not even, yeah, const iterators. So we'll do it this way. Yeah. And oh, you know what? We actually need pairs of these iterators because we need the beginning and we need the ending. Oh no. Oh, that's super awkward. I'm gonna type def this. We actually want pairs of these iterators because we need a reference for the ending. We'll call this, I don't even know what to call this. It's vector pair iter. just call this iter. I'll just call it iterator for now. So this is actually going to be a pair of iterators. Yeah. And the reason is you've got to have R begin and R end. Which seems a little confusing, but it's not really that big of a deal. Okay, so we now have these pairs that we're comparing to each other, and what we're going to do is we're going to take A first, or no, A dot first dereferenced, oops, I didn't mean to do that. Hopefully this is still visible. Oh boy, this is complicated, or this feels like it's getting more complicated. We want, it's going to be, okay, A less than B is sort of the normal comparison that we're going to do, right? So that would be true. So basically, if A dot first is equal to A dot end or A dot second. So that's the thing, is that we want to identify if either of these iterators are sort of finished. And A represents the first iterator and B or the other iterator. Actually, these are it's different now. These are actually pairs of iters. There's two iterators now to consider. Okay. So this is going to be, whichever of these is always going to be the larger one, which means this would return, we want A less than B. A, we're looking at this, right, so A less than B, this would be false, because A is larger. If B dot first equals B dot second, then return true, right? This one is larger, and then otherwise, neither, these can be dereferenced. The first value can be dereferenced. So you have A first dereferenced to second value, and you want the more recent of the two, which is actually going to be the larger of the two. And then that's A, B first, second, which is a little confusing. I realize this is really confusing. There's a lot going on here with this. I don't know if this is good. I'm looking at it, like, I don't know. It's kind of, we're using iterators to do this. There's probably a better way to do this. It's cleaner. Gonna try it in my own. Yeah, give it a shot. Yeah, try it, go for it. Excuse me. So now this is going to give us a pair now, and we say if it first is not equal to it second, Then we want to ret.pushback it, the dereferencing of it first. And we're going to say this iterator and iters. So this it, we actually want a reference. This it first, we're going to increment. Yeah, it's a little confusing. I want to see if this will compile. We'll start with that. Okay. No matching member function for P. Pushback. Iters. Iter pair. And this vector. Pushback P, which is this. Oh, these aren't vector of integers, are they? Wait, tweets per user. These are, oh yeah, no, these are, const iterators, they should be. Oh, what's the issue? Is that because these can't be const iterators? Normal iterator? Maybe that's what the issue is. No. They have to be reverse iterator. Oh yeah. Can you do const reverse iterator? Is that a thing? Oh yeah, look at that. Now, I don't think these are const reverse iterators. Because we are going to modify the iterators. Are we? Well, we can't use the reference because that'll cause some issues, right? Can't bind the type normal iterator. Temporary of type normal iterator. Non-const style value reference. Excuse me. Yeah. I guess these can't be const reverse iterators. I don't know. Not sure now. Can make them not const, just make them reverse. However, oh, can these not be const anymore? Well, this kind of doesn't matter. I'm very confused now. Very confused now. Let's see. Almost an hour. Okay. Not great, but dropping some frames here and there. Not sure exactly why. Let's see. I think we're okay. So, what's going on? What's wrong? What's happening? we can just check this. If we just do auto it, oh, it actually compiles. Okay. But the problem with this being not a reference is that this is so confusing. But this gets the pointer in the iterators, and what we're going to do is then take that pointer, and that's pointing to a pair of iterators, and we're going to update, we're going to dereference it to get the pair. So it gives you the pair of iterators, and then if you call dot first on that pair, that gives you the first iterator. So this is fine, yeah, the first iterator, second iterator. However, you actually want to get, yeah, you want to get this. Dereference that first iterator. Isn't that what I had? Doesn't that give you an integer? And then you also want to take that first iterator and update it. What is going on? What? It's so confusing. So confusing. Excuse me. We should get some pair of iterators. Get the first and the second pair of iterators, and then yeah, then we. Isn't this an integer? Am I crazy? Am I nuts? No viable conversion from standard pair of int to int to int. This is an okay, this is an iterator into a vector of pairs of iterators, and we dereference the iterator to get a pair, and then we get the first is an iterator, right? And this iterator is an iterator into a vector of pairs, and that's why we're having issues, because when you dereference this, it's still the, oh man, that's pretty wild. There you go. And actually, yeah, is that, oh boy. Runtime error, nice. And we say it is not equal to it.end and or iters.end. Wrong answer, nice. There we go. Oh, and there's one more piece here. I forgot. Followees per user. also iterators pushback. You ready for this? Tweets per user, your own tweets of your own ID. Or we'll just say auto T. At that point you can okay. Alright, there we go. Got it. Wow, brother. This was really way more complicated than I was hoping it to be, though. This wasn't supposed to be this difficult. Also, I'm wondering if I do const reverse iterator. Oh, so it does work. Okay, yeah, that shouldn't be a problem. I was gonna say, I'm pretty sure those are const iterators. So this part's not too complicated. I think I like writing it like this, right? We have a reference, we have the tweets, and then here, this is kind of funky. This took me a while to kind of think through. Let me just make sure it's still right. I'm afraid to run this, run some more test cases. I don't even know if it's corrected. It works on this test case, but we need more test cases. This took me forever to get this right. This was really tricky. So this was, yeah, the reason why we ran into a problem is because this is a list of iterators. It's a list of iterators to pairs, and these are pairs of iterators themselves, and those iterators are into a list of yet another list of iterator of pairs. Excuse me. So it's not that bad if you understand it, but it's kind of difficult to keep track of all of that. So when you actually get that iterator, it's an iterator to a pair, right, of integers. And so if you want to get the integer, you need to get the it's an iterator to a pair of iterators. So you get the first iterator there, because the second iterator is just the end. Basically just represents like the end of that iterator, I guess. Like if as your iterator increases, it's going to hit that ending, and then that iterator that you get the first of, it actually dereferenced is a pair of integers. So when you dereference that, this it first is a pair of integers, and then, excuse me, it's an iterator to a pair of integers. I'm sorry, it's not a pair of integers. It's an iterator to a pair of integers. So you dereference it, you get a pair of integers, and then you want to get the first of those integers because the second integer is the timestamp that you're sorting on. So yeah, it ended up getting a little bit complicated. But I think this is correct. I'm afraid to run this on, I don't know, can we run this on a test case? Should we just go for it? I don't want to go for it because we already spent so much time, and if it's wrong, I'd be sad. You know, I feel like I should run a couple more test cases. Just do some random data, you know, random test cases. Can we maybe we can do like a degenerate case as well. So let's try that. Let's do three, yeah, we'll do, oops. We'll do 4 test cases, and we'll do a degenerate case. So we'll just do, I don't know, like, let's get newsfeed. Of nothing. I think get newsfeed is user 1, right? Alright, let's try that test case first. I think we actually do run into issues if we do this. Oh, no, we're fine. So the reason it works fine, even though there's nothing in these, is that each of these things basically, even though they don't necessarily exist, they get default constructed once you call this. So they will exist, but they just won't have anything in them. So this should work. Try this one, I got wrong answer. Sure. Yeah, that's good call. Let's give it a shot. So, post tweet 1-1, get newsfeed 1, follow 2 follows 1, get newsfeed of 2. You should get another. You should get 1 again. Unfollow 2-1, get newsfeed 2. This should be empty after that. Let's see. What do we get? Moment of truth. Yeah, we got it. We're in good shape. Alright, let's see. Thank you for that. Also, thank you for that one. What are the things we could test? Let's add a 3rd user in here, and let's unfollow. Let's add like 2 more users, and do some follows and posts for those users. Yeah, let's do that. So we're gonna take this one, put it at the bottom, and follow, post tweet, newsfeed. And we're gonna keep this as it is. So let's do post tweet for user. Let's do 3, and the tweet ID. Now you got to be careful of the tweet IDs. They've got to have unique IDs. So we'll do like 10. Our tweet IDs are going to be 10. And then we'll post another tweet from 4. It'll be 11. Alright, so post a couple tweets from these users. 3 and 4. Let's do another one from 3. Let's do 3 of 12. And then let's follow 1, follow 3. And then 1, follow 4. So 1, follow 3, 1, follow 4. Oh man, there's like all kinds of tests I would want to do. And then let's get news feeds of 1. Or get the news feed of 1. Alright, let's go with this. Let's see what happens here. Okay, that's correct. Now my question is, even though this is correct, are we going to get are we going to get a timeout? In other words, is this going to be efficient enough? That's the main question. Is this going to be efficient enough? And we could say unfollow, follow one from, or not unfollow one, but unfollow, I guess, yeah, one from 4, or one from 4. And then let's do get newsfeed for 1. And then let's do, oh, I don't know. If we do, let's do 4 follows 3, and then newsfeed for 4. What happens when we do this? I don't really know what my test case should look like now. You know, I don't really. All right, I think we're gonna go for it. I'm afraid to hit the button. I'm afraid. Oh man. Yeah, there's too many test cases for me to think about. There's like too many different ones. Maybe. What's wrong? Wait. What is it? What? five. How did that happen? Post tweet. Follow. Oh. You can't follow yourself. Okay. I didn't think about that. Oh no. I didn't think about that, following yourself. That's such a subtle thing. I did consider, like, yeah, I didn't even, oh man, all right, let's try again. There's probably something else there too, somewhere. Oh man, I was so close. I was so close. I did actually think about this. I was like, oh yeah, well, so if it's idempotent as a set, so that way if you follow people multiple times, but I didn't think about following yourself. Excuse me. Because, I should have done it this way, actually. I got a better one. I have a better idea. What I should have done is not even add that piece of code, but actually, as soon as you exist, you follow yourself. And you say, all right, how about that? All right, let's go for it. Oh no, now it's wrong. Oh no, I did it wrong. Oh, I should have done it this way then. No, I had it right the first time. Because now, every time you post, but now you're gonna unfollow yourself. And then you won't print anything, but you should always print, that was wrong. No, so I had it right the first time. Okay, never mind. Yeah, there's too many, like, Okay. Fair enough. There's too many, like I was saying, there's like too many different test cases, too many different like ways these pieces interact with each other where you can get it wrong. I'm so sad that I got it wrong though. Ah, it sucks. Yeah, it should just be idempotent, like you just always print your own tweets. You don't try to guarantee that you exist in the set though, because excuse me, when you unfollow, you can remove yourself from the set. So you have to tweet again in order to actually get your tweets, which is confusing and not what they're looking for. So you just always are there, added in, and you're not added in twice though, because you could be following yourself. You would ignore yourself if you're following yourself, because you're gonna be there anyway. Oh man, that's such a subtle thing. I feel like I did so well. I did so well. That one test case. I didn't think about that. Never did this kinds of problems. I like more code force kind of problems. Yeah. I mean, I don't know. I mean, I guess it is what it is. Let's see, code force. I don't know what's the difference between code force and LeetCode. What is this? I just want to see like an example. I don't know. I haven't really used code forces very much. At all, actually. Problem set. Let's try that. Genius's Gambit. Name. What are these? Difficulty. Solved. Submit. Let's go like. Oh, okay. So this is the hardest difficulty. And this is the easiest difficulty. Huh. Bit plus plus. I don't know. C plus equals. Two rabbits. Is there really a difference between these? I don't know. Although the LeetCode is kind of intended for interview questions that tech companies will ask you, so it does get a little bit more, like this is somewhat like a design question. So it is a little more, a little less math tends to be, a little bit more like geared towards like actual things that exist, like Twitter, for instance. So, dude, I got wrecked though. I don't know about this question. I'm like, I technically could have thought of that use case, but like I said, there's like so many little details involved with like how these things interact with each other, and like trying to test for all those different combinations of things is kind of just really awkward. I could have at least thought of that though, like reminded myself that if you're going to print your own, list, if you're going to include your own list along with your followees list, then you got to be very, very careful about how you do that, and make sure you don't print it twice, and then make sure you don't print it 0 times, right? Print it more than once or print it 0 times. And printing it more than once would be, if we didn't use a set here, it could end up being printed more than once. Also, if we followed ourselves in this loop, we could have it printed more than once, which I didn't think about that because I kind of added this at the end and I was like, oh, I know how to fix that, but I didn't think about it. So if you have, yeah, if you're, that's like a very subtle thing. It's really subtle. I don't really know how I could, I mean, now that I've done it, I might remember it in the future, but like, that's one that I probably would forget. That's one that I probably miss. But yeah, we did okay as far as the timing. That's what I was thinking about, was how efficient this would be. Oh wow, what happened? Why are we so much slower now? That one was 60 milliseconds instead of 30. That was twice as slow. We did so well originally. We had 28 milliseconds. What happened? There we go. We're almost 99%. We're way up there in our speed. We're way up there in speed. Anyway, all right. I'm gonna end the stream on that one. I'm actually going to. I'm not gonna end the stream. Well, I'll explain what I'm gonna do. I'm going to. What do you call that? I'm going to. It's not my bedtime yet. I've got a little more time, so I'm going to actually start another problem. But what I want to do is I want this video to be just this problem, and then I'll start another stream with another problem. So I'll probably do that in a few minutes. That's going to be the plan. I never did those kind of problems. Code Force. Go to problems on the top. The problems are more on algorithms and data structure, not on software engineering. Yes, you're right. Yeah, I think that's. Yeah, I agree. Yeah, I think so. I agree with you on that. All right. So, okay, I'll be back. Thank you for watching, everyone. Come by and